Okay, so today we're going to be talking about the hypotenuse leg congruence theorem. So far you guys have learned about some of the congruence theorems, the shortcuts, right, to proving triangles congruent, like angle, angle, side, angle, side, angle, side, angle, side, 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 side. Today we're going to be learning about the hypotenuse leg congruence theorem, okay? This is a special congruence theorem that only happens in right triangles. So we can't use this congruence theorem if we do not have a right triangle. We must have a right triangle in order to use it, okay? So here's what the theorem says. It says if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of a second right triangle, then the two triangles are congruent, okay? So it's basically saying as long as you have a hypotenuse and a leg marked congruent in one triangle, hypotenuse leg, and in the other triangle you also have hypotenuse leg, then that means the two triangles are going to be congruent, okay? So here's your hypotenuse, here's your leg, here's your hypotenuse, here's your leg, right? So you have to have a hypotenuse in each triangle marked congruent. Then you must also have a leg in each triangle marked congruent, okay? Now, remember, the entire triangle has to be a right angle, so you must know that it is a right triangle because it has a right angle marking, okay, in each triangle. All right, so knowing this theorem, knowing that if we have a right triangle and we have a hypotenuse and a leg, congruent to another hypotenuse and a leg, and it makes the two triangles congruent, we're going to go ahead and run through some examples. Okay, so example set A says, does the diagram give enough information to show that the triangles are congruent? If so, state the postulate or theorem you would use. So some of these are going to be using new congruence theorems. Some of them we might have to refer back to old congruence theorems we've learned. But let's take a look at the first problem. I have a right triangle here. I also have a right triangle here. I see that I have the hypotenuse of the first triangle, and I also have the hypotenuse of the second triangle marked congruent. I have a leg on the first triangle and a leg on the second triangle marked congruent. Okay, so I have hypotenuse leg on the first one, and I also have hypotenuse leg on the second one. Therefore, I can use the new theorem that I just learned. So, yes, triangle ABC is congruent to, if I call this one ABC, I'm going to call this one corresponding in the correct order EDC. By the hypotenuse leg theorem. Just abbreviating that word theorem. Okay. All right, let's move on to number 2. Okay, so looking at number 2, I don't see any right angles here. So hypotenuse leg congruence theorem is not going to apply to this. I have to go back to my old congruence theorems that I know. Like, for example, angle, side, angle, side, angle, side, 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 so forth, right? So I see here that I have parallel lines. Okay. Parallel lines means there's going to be some alternate interior angles that I can mark congruent. So I can mark this angle here and this angle here congruent. So that's one set of angles that I can go ahead and say are the same. Okay, I can also mark this alternate interior and this alternate interior angle congruent, right? So these two can be marked congruent. So that's another set of angles that are congruent. And last, I do see that these two triangles are sharing a back-to-back wall or a common side. So I can mark that common side congruent to itself and use that as part of my evidence for why I can prove them congruent. So here I have angle, side, angle, and in the other triangle, angle, side, angle. So these two triangles are going to be congruent. So yes, Let's use the top triangle first. Triangle RUS is going to be congruent to, now if I call this one RUS, look at the order I went in. No markings to green to pink. I have to do the same order in the other triangle. No markings. So that would be triangle T to green, next S, and then U. All right. And this one was by the angle side angle postulate. All right. Take a moment to take a look at number 3, see if you can work in your groups to go ahead and figure out what you would write down for number 3. Okay, hopefully you guys have had enough time to work in your groups to discuss number 3. Okay, on number 3, we see that we have 2 right triangles. Okay, so I'm going to look for and see, do I have a hypotenuse and a leg that I can say are congruent? I definitely have a leg. Here's a leg, here's a leg. These 2 legs are congruent. I also have these 2 legs over here. Okay. Now, as far as the hypotenuse being congruent, yes, it is congruent because it's actually a common side, so I can mark it congruent to itself. Now, there's actually a lot of different reasons why you could say these 2 triangles are congruent. You could say they're congruent because of hypotenuse leg. You could also say they're congruent because they each have side, side, side. Or you could even say they're congruent because they have side, angle, side. So a lot of different reasons here, but since the new one we're learning about is hypotenuse leg congruence theorem, I'm going to say that's the reason why. So yes, triangle JML is congruent to, if I went JML here, I'm going to do some highlighting so maybe it's easier for you guys to see in the other triangle what's corresponding. Okay, so if I went JML over here, J is where the pink and the orange come together in this triangle. So in the other triangle where the pink and the orange come together is L, so it would be starting with L. Okay, and if I went JML, I went along the pink line here, so L, K, J. Okay, and I'm going to say by hypotenuse leg theorem. Okay, because I had a hypotenuse and I also had a leg. You could use either leg as your reason, your evidence. Okay. Okay, let's go ahead and take a look at the last set of examples. Okay, in the last set of examples, we want to tell whether the theorem or postulate can be used to show that triangle LMN is congruent to triangle QMP. So LMN is this triangle over here, and QMP is right here. All right, so we want to check if we can use these postulates to show congruence. So the first one is angle, side, angle. So I see here that I have only one angle marked congruent, but if I look at this picture, what do I know about these 2 angles? What kind of angles are they? They are vertical angles, so I could actually mark those congruent to each other. Now that I have marked those vertical angles congruent, can I show angle, side, angle? Angle, side, angle. Yes, okay. So this one would be yes. Okay. Let's take a look at number 2. Angle, angle, side. Okay. So if I'm looking for angle, angle, side, do I have anything marked right now that is proving angle, angle, side? Well, not yet, but because I know these 2 angles are congruent, and I know these 2 angles are congruent, then by default, if you know 2 of the angles are congruent in a triangle to each other, then there's a theorem that says the third angle has to be congruent, so I know that these ones also have to be congruent. So now maybe can I show angle, angle, side? Angle, angle, side. Angle, angle, side. I could also go around this way. Angle, angle, side. Angle, angle, side. So this one would be a yes. And that's because I use the third angle theorem here. If two angles of the triangle are congruent to two angles of the other triangle, then their third angle has to be congruent. Okay, let's look at number 3, hypotenuse leg. Okay, so do we actually have that the hypotenuse is marked congruent? No, we don't have the hypotenuse is marked congruent. Okay, we can't mark them congruent based on they're not a common side, so they're not back to back. However, you've already shown several different ways that these two triangles are congruent. So because these two triangles are congruent because of all these other things, we know that the hypotenuse is going to be congruent. However, we're not going to say that we wouldn't use this theorem to prove their congruence. We would use another theorem. So we're going to say no on this one, okay? Because we wouldn't use that to prove congruence. We would probably use one of the other ones over that one, okay? And then the last one, side, 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 okay, again, we weren't given any information, okay, to show that these two sides were congruent, the final third side. So we're going to say no on this one as well, even though I know because the two triangles are congruent that those sides will end up being congruent. I can't use this theorem or this theorem to prove it. I could use either of these because I can draw conclusions about the angles from other theorems that are not congruence theorems that I know. Okay? All right, are there any questions? Okay. You guys are going to staple this onto page 22 in your notebook. So on page 22 in your notebook, okay, in your table of contents, your title in your table of contents for page 22 should be hypotenuse leg congruence theorem. Okay, so you can write that down as your title in your table of contents and then get this stapled in where it belongs.